Right, so should children play more computer games? Really, actually, I want to tell you about a journey of mine to virtual worlds as a way, really, to go to my audience. I'm a science communicator. I go out and around trying to inspire, enthuse people about science. One of my real aims is actually just to get people to appreciate science for its own right, just as they do, just as you might a concert. You go to a concert, you hear some fabulous music, you don't come out of the concert thinking, now I know how a cello works. Same sort of thing with science and science communication. I want people to come away from events thinking, wow, that was interesting, and I enjoyed it, and that's enough. Okay, so, but to do that, you really have to maybe go to the audience. You've come here today to speak, to listen to me and hear many other people speaking. You've come to us. How do I go to them, though? The people that, those other people that may not have ever come to an event like this, or a science communication event, or a science festival, or whatever. So, to move on a bit then, what I want to do now is tell you about the sorts of messages that I might want to get across to people. And I'm going to start then by asking you a question. Who can name me a famous physicist? Yes?
Rutherford.
Rutherford, excellent. Got any some more? Go on, yes, yell them out.
Isaac
Newton. Yeah, Bohr, excellent. Right, biologists. Darwin, yeah, a few more there. Chemists. Boots, yes, boots. Exactly the answer I was looking for. Boots, right. Okay, so last year, the Royal Society of Chemistry, the RSC, the Royal Society of Chemistry, so not the Royal Shakespeare Company, published a study on the UK's public's perceptions of chemists, chemistry, and chemicals. And what they saw is that with reference to chemistry, most people think, well, of Bunsen burners and test tubes and, sort of little models maybe, if they're lucky, like this sort of thing. And that's about it. They haven't necessarily got a real clear idea about what chemists, and by that I mean chemical scientists, do. Chemicals. The chemistry community was really scared that people were scared of chemicals. All a bit meta, that. But actually that didn't materialise. People, don't really think much about chemicals. And then, as far as chemists go, as your answer already suggested, people think we work in boots, in high street pharmacists. So there's this void around chemistry and what chemists and chemical scientists or science tells us. And that's a shame, because chemistry has really built the world around us. Yeah, with just 100 odd building blocks, you can build the world and everything in it. And where humans fail nature with the power of time and evolution, has managed to create all living things that we see on our planet. So with those just 100 ingredients, you think about it, and all this world around us has been created. And here's, if you want then your own, for example, Professor Lorch, here's my ingredients list, okay? They're on my back, yeah. Unfortunately, I don't have the recipe, okay? We have the ingredients, but we don't have the recipe, for human life at least. But we do have the recipe for a whole raft of other things, agrochemicals, materials, your plastics, the very fabric of your flat screen devices. All of that has been devised by chemists and chemicals. And of course, they have devised pharmaceuticals, drugs as well. So here's another question for you. Who here took the opportunity during the break to take a psychoactive drug? No? Maybe you were feeling a bit, sleepy, worried you're going to nod off. Yeah, needed a bit of a upper. Or perhaps you wanted to relax a little, take something that might, chill you out a bit. And the wager that many of you did, caffeine. Yeah, the most commonly consumed psychoactive drug in the world. Ethanol, probably the second most common, okay? They are, of course, made, from these chemicals and these lovely molecular models that I use quite a lot for teaching chemistry. And they're, you may be familiar with these sort of things. So the blue blobs, they're nitrogen atoms, and the red ones, they are oxygens, and the black ones there are carbons, and the white are hydrogens, okay? And similar thing there. Now, these are great. I mean, I think they're lovely, they're tactile, they're really good, good, accurate models, but they aren't really super accessible to, say, children in schools, especially primary school children. They're expensive, for one thing, and they're actually quite tricky to work with in a lot of ways. So I often actually prefer something else, something a bit more manageable, something like jelly babies. Jelly babies. Why not build molecular models with jelly babies? Oh, I've got the wrong atoms on there. There we go. Okay, here we go. Right, carbon dioxide, if you will. Yes? Okay. Or we can get some. How about a water molecule as well? There we go. Water. Okay. Water molecules. You don't need all this fancy stuff that costs a fortune to make chemistry and molecular modelling accessible. But actually, I'm more interested actually in much bigger molecules than this. I really am passionate about these sorts of things. So these are proteins. These are the molecular machines that do all the jobs in your cells. They replicate your DNA. They fight infection. They digest your food. Your hair is made from proteins. If there is a process going on in your body, proteins are involved. And they're huge molecules. They're made up of long, thin strings. My cherry lace here, and they fold up into very, very well-defined structures. Okay, unfortunately, confectionery sort of breaks down a bit, isn't quite up to the job of modelling molecular proteins, although I can just about pull off DNA. Okay, right. So there we go. This sort of thing I do use, but I really wanted to go to a wider audience, a much bigger audience than I can by building models like this at schools and science festivals and the like. I wanted something that, you know, the kids today really enjoy, that's creative, that's powerful, and that they're into. I wanted to go to their environment. And what do they like doing? Games. Games they love. Okay, I love games. Computer games are fabulous in so many ways, and they're very, very engaging. So what if we could take this and somehow put it into a game that kids will really enjoy? Okay, there we go. Right, so this is where we discover the wonders of Minecraft. Right. Minecraft is a fabulous tool. Now, some of you may have encountered this before. Some of you may have told your offspring to go and do something more useful. I will argue to you there now that this is extremely useful. Okay, first off, of course, it's just a building game. Yeah, it's digital Lego. You can build with a whole variety of different objects. So there's some clay, there's some sand. You can quickly knock up a structure. But it does much more than that, because this, it actually has almost basic electronics in it as well. So you can build logic gates. So this is an input-output. I flick the switch, that block at the back goes on. Yeah, this is a NOT gate. So now when the switch isn't on, that lights up. Okay, see they're in opposite orientations. We can do AND gates. When that one and that one are on, it lights up. Yeah, or OR gates. If that one or the other one is on, yeah, that comes on, right? And XOR gates and much, much more. And in fact, you can build whole computing computers within Minecraft, yeah, using these sorts of logic gates. So Minecraft is really, there's much more to it than just building, you know, structures, etc. And there's been a whole raft of organisations that have cottoned onto this. This one, for example, yeah, is developed by the Geological Society and in conjunction with the Ordnance Survey. This world is the whole of the UK Ordnance Survey map ported into Minecraft. Okay, so you of course will recognise this, don't you? This is Derby, right? We are over. We're just down there, round about where my cursor is. Yeah, and if I show you a map, there you go. Look at these. This is where we are. Look at those features there in the loops of the. There they are, down there in Minecraft. But it gets better than this world, because you can also dig down and see what is under your feet. So there's clay under here. Yeah, that's clay. We could fly up to the hills. Yeah, head up into the, if we fly far enough, we'll find the Peak District. Or more clay there. There's some sandstone over here, I'm sure there is. Okay, but you can find the whole of the UK, and there you go, some bedrock there, etc. as well. So you can investigate the geology of the UK using Minecraft. Right. So it's got me thinking. Well, this is really fabulous stuff, but I'm interested in chemistry. How can I take this and take structures, take information, put it into Minecraft? So what I did is we run undergraduate projects at the university, and I set up a project for a group of students to try and figure out exactly that. How do they get structures like these and structures like those proteins I showed you into Minecraft? Strangely, they were really quite keen on the idea. They for some reason thought that might be more interesting than some of the bench work that their colleagues were doing. Not that bench work isn't interesting, but yeah, there was a fair old group of them that wanted to have a go at this. So this is what they constructed. Okay, so they constructed a world. Oh, look at that, and it's populated with other people as well. Yeah. Ooh. Yeah. Oops. Sorry. T. There we go. Try again. I can't type. There we go. Now this is my fellow creator, Joel. Okay, and we've created a world where people can log into this world. We can interact with them. Yeah, so I can get on this world. There are people all over the world who can log into it. I can teach them chemistry in Minecraft. I have given biochemistry lessons to kids in Minecraft. Right, let's go. And so this is then a lobby area. Okay, and if we nip in here, you will see a whole load of information appear about molecules, and that's just being a bit laggy. But you can start to see a structure appearing that looks very similar to the sorts of things we've got here, and it uses all the same colour schemes. You've got whites for hydrogens and blacks for carbons, etc. Yeah, they can, and there's more. So if I nip back over here, and just need to jump on this, we can go and find structures. So let's have a look at myoglobin, for example. So you remember those twisty-turny structures we saw before? Well, here one is again, now all in Minecraft form. Yeah, and this then allows any students as well to explore the structures of proteins, see the intricacies, and do all sorts of activities within the world that you really can't do with a lace. Okay. So, for example, in here, this is myoglobin. As I said, this is responsible for carrying oxygen around your muscles. Within the centre of the molecule, there is a chest. There we go. And Joel's going to just open up that chest, and he gets given something. Do you see that? He got given a sword. Okay, so that's his prize for having found the chest. Okay, and for having found the object. So there's these chests hidden all over the world, encouraging students to go and explore the world, find out about this, and find about the structures within them. Now, I do want to say actually here, this wasn't created block by block. I hasten to add. This was created by my students figuring out a way of taking information from the structural databases that exist that describe proteins, where scientists deposit all the information about proteins, figuring out a way of porting them wholesale into Minecraft. Right. Now then, so the point here then is that I've really, hopefully, taken this world, taken it to learners, taking it to young people who are already interested in Minecraft, maybe don't have any interest in chemistry. So far, we've had this world downloaded maybe 3,000–4,000 times. We've had several thousand people visit this server. As I said, I've done impromptu chemistry lessons all within this world. It's just one more piece I want to show you. So down here, yeah. Okay. Down here is a map of the UK. On this map are sites of special interest in chemistry around the country. Yeah. And these have been deemed, by the Royal Society of Chemistry as their landmarks. And let's go in here, for example. So up on there, we get teleported to a place in Glasgow, and we get information about Joseph Black, who was a chemist who discovered carbon dioxide. So there we go. I've got a question for you. Can you name me a famous chemist? Joseph Black was the answer. Oh, okay, there we go. Right, so if you want to have a go at this, it's called MolCraft. By all means, it's freely available to download, etc. And I hope I've at least shown you, actually, given the right environments, kids should be playing many more computer games. Thank you.